Let's solve. 4h squared plus 12h equals to negative 24 by completing the square. Now for this example, what you would notice compared to the last four examples that we've completed is that our highest degree term, the coefficient was 1. But for this example, our coefficient is 4. So going back to the how do we complete the square, under number 1, yes, we're going to, for step 1, rearrange the equation so it looks like x squared plus bx plus c, and we're going to fill in, excuse me, is equal to c, and we're going to fill in the missing component by taking half of the middle term, the coefficient of the middle term of x, and squaring that. But it says here, if our leading term, the h squared, if the coefficient is not 1, we want to make it 1. And how do we do that? We're going to divide every term by the coefficient that's in front of the squared term. So for this example, we're going to, the coefficient here for h squared is 4. I want this to be h squared. So what I'm going to do, or what we're going to do first, is divide each term by 4 and reduce. So now we have h squared plus 3h equals to negative 6. So now that we have our leading degree term as the coefficient is 1, now we can complete the square. So I want to fill in this missing component, and whatever we add on the left hand side, we add on the right hand side. So we're going to take half of the middle term of the coefficient of h here. So take half of 3, and then we're going to square it, and then that would give us 9 over 4, because you have 3 times 3, 2 times 2, so this gives us 9/4. Left hand side, this is a perfect square trinomial, so we can factor this h squared plus 3h plus 9 over 4 as h plus 3 over 2 squared equals to, and let's add negative 6 and 9/4. Let's go ahead and do that. Negative 6 plus 9 divided by 4. And I want to convert that to a fraction. So we have negative 15 over 4. All right, so we're going to next use the square root property so we can solve for h. So take the square root to both sides, and you're going to have two solutions. So here we have h plus 3 over 2 equals 2, plus or minus. Now I want to do a side note. Let's look at this right hand side, the square root of negative 15 over 4. Okay, so I want us to write this as two separate radicals, the square root of negative 15 over the square root of 4. Now remember, we do not want to have radicals in the denominator. Okay, and if we have that, we can rationalize if the denominator is not a perfect square. But since our denominator here is a perfect square, the square root of 4 is 2. Now look at your numerator. You have the square root of negative 15. We talked about complex numbers where we want to take out that negative 1 factor. The square root of negative 1 times the square root of 15. 15 we can't do anything to, but we can take the square root of negative 1, which is I. So our numerator will be I square root of 15. So that's what the square root of negative 15 over 4 equals to, which will be I square root of 15, or the square root of negative 15 over 4, which is I square root of 15 all over 2. And then solving for h, we're going to subtract 3 over 2 to both sides. And our solution is h is equal to negative 3 over 2 plus or minus I times the square root of 15 all over 2. There we go.